Hi guys, I hope you're having a really good day. So today we are going to be solving a problem on linked list. So just a brief refresher on what a linked list is. A linked list is a sequence of elements where each element is linked to the next node with a pointer. So it is different from arrays because linked lists are not indexed and we need to traverse them sequentially to reach the end of the list. It is different from doubly linked lists because a doubly linked list has, for each node, there are two pointers. It has a next pointer and a previous pointer. So it can traverse both ways, forward and backwards, whereas singly linked lists can only traverse in a forward direction. So the problem that we are going to be solving today is write a program to find the node at which the intersection of two singly linked lists begins. For example, we have two singly linked lists here, A and B. The elements of A are A1, A2, C1, C2 and C3, and the elements of B are B1, B2, B3, C1, C2, C3. So whenever you have a problem, the best way is to visualize it, and that's what we have done. So if you see that the length of linked list A has 5 nodes and the linked list B has 6 nodes, and we have to find the intersection, which is C1. So the node that we need to return from our function is C1. So if you see both the lists, we can come to know one thing, that if we are able to move the pointer of B1, the head pointer from B1 to B2, and then simultaneously move the pointer at A1 and B2 two times, we can reach C1. So all we need to do is find the length of each of the lists. The second step would be to find the difference, which is 1. Move the pointer of the longer list by 1, and then the last step would be to move each pointer of the list A1 and B of list A and B simultaneously to reach a pointer where the nodes are same. So in this problem, in this example 1, we see that we can move. So the first list is 4, 1, 8, 4 and 5, and the next list is 5, 0, 1, 8, 4 and 5. So what we need to do is we need to move the pointer of B. First we need to find the length of both the lists, the first list being 5 and the second list being 6. Find the difference, which is 1. Move the longer one, which is B, by 1. So the head pointer reaches point 0. Then we move each of the pointers simultaneously, that is move 0 to 1, 4 to 1, then 1 to 8 and then 1 to 8. At this point the nodes are same and we match it and we return it. The second example is we are having a list which is of A is of length 5 and B is length 3. So the difference is 2. We again traverse the longer list by 2. So we reach from point 0 to 1 by moving 2 pointers, that is 0 to 9, 9 to 1. Then moving simultaneously both the pointers to reach 2, which would be the intersection, and we would return it. So let us now go and solve it. First we will do a brute force method the way we are thinking, and then we will optimize it and we'll improve the complexity. So we start coding now. So the first thing that we need to do is find out the lengths of each of the linked lists. So first we find out the length of linked list which has head node as head A, and then we find out the linked list of length of the second linked list. The way we do this is we just use a helper method where we are just we are traversing this linked list sequentially, and until we reach the end of the node, end of the list, we are going to be incrementing the length. So once we do this, find out the length, then we need to find out the difference in both these linked lists, length of the linked list. So find out the difference. Once we do this, we need to traverse the longer list by this difference. Oh, sorry, before this, we need to find out which list is shorter and which list is longer. So that's what we're doing now. We are going to be first finding out the shorter or the longer node by checking the length. And after finding out the shorter and longer node, we will need to traverse the longer list by the difference. So we traverse the longer list until the difference is equal to 0. And after we do this, we are going to be getting 2 pointers, one pointing at the start of the first list and another one is pointing to the second list, and we can simultaneously move the pointers, and exactly when these nodes are equal, we will return the node, because that would be the intersecting node. If you see here, we have not used any additional space. So the space complexity is 1 and the time complexity is order of the length of the first linked list and the length of the second linked list. So if we take length of the first linked list as length A and the next one is length B, so it is order of length A plus length B, but there is no additional space, so it's order 1. We can use this, we can also write this program using hash maps. So the way we would do that is we would save the complete linked list of one of the linked lists in the hash map. Then we would traverse the second linked list and see if there are any matching nodes. And once we find out there are any matching nodes, we would then returns. But in this case, you should know that the space complexity is order of either length A or length B, because we need to store the linked list in the hash map. So these are the two ways. This is a better way because the space complexity is only order 1, whereas in the hash map it will be of order of length A or length B. So thank you very much, and if you want to see more videos, please like and subscribe.